Hello, my name is Matthew and I am the team lead and pilot for the ASME IAM3D challenge at my school, Brigham Young University, Idaho. This year we've been working really hard and I'm eager to show you what we've got. We'll go ahead and start out here in SolidWorks with the design of the drone frame. This drone frame looks pretty complicated, but in essence it is quite simple. It's defined by two sketches here. Two main sketches that I'll show you. This first sketch defines the width and the angle here, and I can change this angle here to get a different symmetrical nature, but I'll go ahead and leave it back at 45 so that it is symmetrical, like the one I have in real life. So that's this first sketch, pretty simple, straightforward, and everything else is defined off of that. We go ahead and look at this next sketch, and this is the sketch that defines the walls, the vertical walls that are extruded up. And so we see the curved sections here that follow the path and are led based on this rectangle here. And this rectangle here is defined by the size of the electronics and the space that our team decided that we needed. So then from here, this turns into an extrude, and we just extrude these walls up at an angle with a thin extrude feature, which creates a aerodynamic and also strong design. The best part about this design, in my opinion, is how easily it's 3D printed. All of this here is flat, and there are no overhangs except for here and here. And I'll go ahead and show you that with a cutout view. And so you can see here that it's got this cutout here. That's just so you can run the wires from the motors to the inside underneath the through the frame instead of over. And I'll show you that in real life as well. So the coolest part about the frame is that it's very easily 3D printable, and that allows you to just click print and it just pumps it out, which is really helpful for prototyping and getting it printed easily, but also if this were to be used in a sort of first responder situation, it'd be very helpful that way too, because it's so easy to print. So we'll go ahead and switch now to the drone assembly and rebuild this, as I've changed some things slightly. Okay, so now you see this is the assembly here, and here are some motors that I've designed, just some basic shapes and some very basic propellers. You can see in here all of these parts are 3D printed, and all of these parts are parts that we intended to build. I'll go ahead and actually take out the not 3D printed parts. Now you can see here these are the 3D printed parts. We have the top plate. We have this here, which is the antenna mount. We have two parts here that go on these posts that are for mounting the camera. These are flexible, 3D printed flexible. This is also flexible. Then down here we have the magnet pickup drop-off mechanism. We have a spot for a servo to sit here, and then we have the servo horn here, and then we have the part that then would attach to the magnetic blocks. As I'll show you in a second, you'll see in real life that we don't have all of these parts printed, and that is because unfortunately the school closed, which meant we were unable to access those 3D printers, which are very reliable and nice. And so we had to rely on one of our team members' 3D printers, and that broke down before we were able to 3D print all the updated parts that you see here. Okay, we'll transition now to the physical versions of these. We'll start here with one of the prototype prints of the 3D frame. This is carbon fiber infused nylon, and this print here looks pretty rough because carbon fiber nylon is very difficult to print with most printers. And we found this in our testing to be very durable. However, the issues with printing are a lot. You struggle with layer adhesion, you struggle with it absorbing moisture, and you struggle with bed adhesion and it pulling up. And you can even see that here, it's not completely flat because it was warping up. So this was a prototype 3D print, and when we tested it, it showed a lot stronger than this here. But this frame here is still very, very strong, and the increased durability here was not worth the expense of the difficulty in printing. So here's the prototype print. You can see the channels here for the wires to travel through, and you can see all this print and how it's built just like the 3D version on the computer. We'll transition over to the assembled quadcopter, and this has the motors, speed controllers, some LEDs, flight controllers, and I'll show you all the 3D printed parts here. So we've got this frame here, of course, that I just showed you the other version of. And then here's the antenna mount in the back. This is again made out of flexible filament, which means when this antenna gets knocked around, it doesn't damage the antenna or the other parts. Over here we have the camera and two 3D printed brackets to hold that on to the top posts. And then we would have had, if we would have had the printer running, we would have had the top plate here, which would have had a battery strap looping around. We had a second version that would allow for a GoPro to be mounted on top. And then we would have had the servo mechanism on the bottom. Unfortunately, since we were unable to print the top plate, we could not mount the battery on the top. And so we had to sort of engineer a solution. And so we ended up using like this heat shrink to hold down the video transmitter and just hot gluing the receiver down. It would have been much neater with the top plate here. However, this is what we had to do because we couldn't print more parts. However, it turned out very nicely, I believe. You can see it just fits very nicely. The parts are smooth. Here's again the wiring going through those holes back to the speed controller. Then you see the speed controller on the bottom here, and then the flight controller on top, which is wired to the camera, the video transmitter, and the motors. So it all works together very seamlessly. And if we would have been able, the servo would have also been hooked up in here and then wired down through the side and down to the bottom where we would have had the servo mechanism. But since we didn't have the top plate, we had no other choice but to mount the battery here. Now that we've looked at the design both in the computer and in real life, we'll now transition over to showing you some flight footage of this drone operating. We mounted a GoPro to the bottom of the battery to hold that on there, and so that you could also see the frame in the view, which makes it pretty neat to be able to see how it responds and how smoothly it is able to fly, considering that it is 3D printed. So we'll go ahead and transition to that footage now. Thanks.